All right, so I got a little interrupted, but so what we were doing, we're continuing with annotating Contig 25, but you get the idea. What we're doing is seeing if the coordinates, the beginning and end coordinates of our query match up at all with our Contig. So I'm gonna just check out the end of this, and I'm gonna go to the end of this hit, and now we're 426040, which is within our Contig, within the range of our Contig. So that was, I believe, this one. And I just kind of want to poke around here. I'm just going to poke around and see if I can find something in here that actually matches the beginning and then also falls within our Contig, because so far we're not having any luck with that. Okay. Yeah, so the end of it matches with our Contig, but the beginning not so much. And so this, we haven't really found a good solid hit for either of these, frankly. And so it's still a little, so both of them at this point are still candidates for possibly being on this Contig as far as I'm concerned. All right, so I'm just going to take a look at this a little more closely. I'm going to just zoom in here. And I need to adjust some things on here because I should be seeing an arrow here and I'm not. And so I'm going to see what I can do to turn it on. So face positions are full. All right, so it looks like if I actually zoom out or zoom in far enough, I'll be able to get my arrow. The other thing, all right, so in kind of blasting these two genes against the elegans assembly, we didn't really get a great view of that, but let's look at the other lines of evidence that we have. All right, so here are all of our gene predictions from different algorithms. We like to start with GenScan just because GenScan tends to over-predict. And so it's not likely to miss things. It is likely to think there are things there that actually aren't, and so you investigate them and you find out really there's nothing there. And that's okay. That's actually better than missing things that were actually there. And so we tend to start with the GenScan prediction algorithm, those results, because they do tend to over-predict where things are. So let's take a look. I mean, these predictions are very much lining up all together, and they match the BT gene more than they do the SLS gene. Okay, so the length of these exons, these putative exons, and then there's the presence of this one that seems to be there. And as we scroll down, let's see what's going on, right? And so it's fairly consistent all the way across, that these seem to be lining up with BT. So now I can say, well, okay, we did not get great blast results with either of these genes, but BT matches the GenScan and the other predictions much more closely. And not only that, but they match the RNA-seq data as well. And so these peaks are lining up pretty nicely with both the predictions and with the blast hit for alignment to melanogaster for this particular gene. So that's actually a pretty decent indication that we are actually looking at BT. Okay, so I feel like we can go ahead and get started with this. So at this point, I'm just going to start with the first exon, and what we're going to do, one thing that you can do and I think the annotation took you through this, is to go, okay, so I'm gonna click on this again, and instead of clicking on the flybase ID, I'm gonna click on the subject name. And what this is gonna do is it's gonna give me the exon sequences. All right, so here are the polypeptide or protein details, and so this is what we're gonna be concerned with. Recall that the polypeptide details, which is the CDS, the coding DNA sequence, is going to see, this is CDS usage map. This is going to differ from the transcript details. This is the exon usage map, because there are sometimes, often, usually, untranslated regions, UTRs, that are exons that are transcribed in the, they show up in the transcript, but they don't show up in the polypeptide because they're not translated. That's why they're called untranslated regions. So for now, we're going to stick with the CDS, the translated exons, and we're just going to kind of go through, and I'm just going to click through on these and see what they look like. And I'm going to actually start. So what we're going to do is we're going to kind of go through these, and we're going to blast each one against the elegance, actually against the Contig, to try to find out where in the Contig do we think this actually is, and that's going to give us a ballpark for where we expect to find it. Okay, and so this is kind of a behemoth. It's got it's got a lot of exons. So I'm going to actually just go back for a second, and I'm going to zoom out, because what I like to do is I like to start with the biggest exon, because that tends to anchor where I'm sure the gene actually is. The largest exons tend to be more conserved and therefore easier to find with BLAST. And so I'm just going to kind of gauge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. I could have just counted from the end. So maybe somewhere around exon 35, I'm going to end up with a really nice big Contig. And that's it. Wow, so nice when it comes together. Wow, that's a really big exon. Okay, so I'm going to copy this, and I'm going to go to flybase blast, and I'll go here. Clear this sequence. Ooh, we're not doing it in blast. We are doing it in blast, but we're doing it in the NCBI blast. So I just went to NCBI blast, and I am going to do a T-blast N. I'm going to align 2 or more sequences. I'm going to enter this as my query, and I am going to choose there it is. I'm going to choose my FASTA file. All right, so I think at this point we're also changing some parameters. And these all look fine. I think I'm clicking filtering low complexity regions. All right. Wow, look, I didn't even have to pause it because it was so fast. One beautiful hit. All right, so we have a single significant alignment. It looks great. All right, so here is where we are going to be noting some coordinates. All right, and the way we're going to keep track of this is we're going to go back to, whoops, I'm going to go back to the folder. I'm going to go to, let's see. All right, I'm looking for this in the folder and I can't find it because it's not there. So what we can do is we go to our gene record finder and we can download our CDS workbook. And I am going to put it within the folder, and that's why I was looking for it there, because I always put it there. But you download it from the gene record finder. So this is going to end up being a little way that we can keep track of things like phase and potential positions. All right, so this is going to be a spreadsheet. It's listing all of there's workbooks for each isoform. And these are all of the unique exons all together. And so what we can do is here's our, that's our coordinates in melanogaster. Here's going to be our coordinates in elegans. And so we're going to go back to blast, and this is our exon 399642. 399642. So that's where we're at, and we want to note down our coordinates. So here's 40368. I'm just going to copy and paste this. And I'm going to scroll down. So that's where that is. Those are our coordinates. I'm just going to do this thing. And our ortholog strand, let's see. So we're in +3, and it's going to be plus. All of these are going to be plus. Whoops, that is not what I meant. Okay, I'm just going to ignore that. We know it's plus. I'm not going to, oh, here, DML strand. Here, I'm going to do a little apostrophe, and that way it'll just keep the way it is. And we're in +3. Hopefully that will not, all right, anyway, that's fine. Yeah, whatever. Anyway, you know what I'm talking about. I'm just going to call it 3, and we know that there's a plus there. I'm going to get rid of this comments, and I am going to add donor phase, acceptor phase, because I'll fill those in as I'm going through so I can keep track. All right, so that's our biggest one, and I will work out from there. So I'm just going to go through. I cannot believe I picked a gene with 43 exons. Okay, so I'll do 38 now, exon 38, blast that, hopefully it'll be, so basically what I'm going to do is I'm going to go through and blast all of these and write down the, whoops, that's not where I am. I'm going to write down the coordinates for all of them and just fill in that chart. And then we get to go and compare them. All right, so I'll do one more, and then we'll start looking and seeing where they actually are. But in theory, you would do that for, why is it not blasting? What is happening? Alright, so that was weird. So I just hit refresh and it just cleared everything, and so I can just start over, which is fine. I'm okay with that. Alright, now we're going. Okay, and we got a single hit. It's okay, it's not great, but that's okay because it was a much smaller query length. And so we've got it, it's 99 nucleotides or amino acids, I guess, long, and so our starting is 4007. We're in the +2 frame now. 4007, 4007.